Yeah, okay, fine. Hey, it's Coffee Compiler Club. Here to talk about compilers, but many other topics have already crossed our lips this morning because we had a lot of fun stuff to catch up on. I think everyone here has heard the spiel before. I'll record, get it up on YouTube at some point. I'm going to throw a status dump. I live in the Santa Cruz Mountains now. We had huge winter storms. They dropped trees left and right, which took out every kind of power line and blocked all roads. At this point, I now have electric power. I do not have gas. I have no heat. The sun is out. The day is pleasant. The house isn't too bad. So I'm whining more than I'm suffering. I have an electric heater at my feet too. So, it's not that bad. Um, I missed last week for having no internet, for lines being down everywhere. I know a meeting went by. I have a video somewhere I need to go put up. That will happen at some future date. Um, we have a couple new people who were demoing stuff last week. We're hoping that they'll show up this week and we can talk about it. And if not, then that's fine. Other things, I've got some AA crunching going along. I have passed a bunch more of my mainstream tests. I'm probably going to push back to master at some point. Long ways to go on master side, but it crossed some threshold and suddenly things started working much quicker, easier. Like I'm fixing stupid bugs today instead of hard, in-depth, theoretically tough bugs. So that was a good step forward. That's my main update. If we want to get into AA, I'll show you some of the stuff that's back to working again. In particular, some of the nasty things that we talked about in theory in month past
Sure, why
are
not?
now testing. Is that
Sure.
a sure we do the thing here? Let me go pull up something here. Actually, let me go share the Google Docs. I want to get more text. I have to read them all. Miller cutoff is also shit. Gas truck got turned around on Miller Hill. Shit. I think he's trying to get here. The road's cut for because they got power lines down. I don't know if Lisa can get out. She was going to get another electric heater and the gas truck can get in. That's going to suck. All right, what was I doing now? I was trying to share. Oh, Zoom. I'm trying to share. Thank you. Hello, Zoom. Zoom, yes. Where's the fucking share button these days? There we go. Oh, and Dan's trying to get in. All right, let me hit the share button. Let me go back to finding Dan. Participants. Okay, they hit it again. Dan, yes, Dan, admit. Okay, they moved it to a new window. Jeez. This all got a lot more difficult than necessary here. Okay. I claim there's no one else waiting to get in, and I'll try again here. Yeah, okay, fine. So what was I grabbing and cutting and pasting? So here's I'm going to step up from a few examples here. So code blocks already pre-formatted. Yeah, this is like, and we don't need these because it's just written in a JUnit test. Yeah, so here's a function that takes a G. He assigns a value to F. This is all crammed on one line, so it looks easier in the testing, but you probably actually want to do a little formatting here. So a function, I'm returning the whole thing's type is a function which takes a G. Inside there's a function F, which just ignores its argument, returns that G, and then I call F twice.
Mm-hmm.
I make a pair and return it. And what happens here is F is fresh in the Hindley Milner fresh sense in the
Mm-hmm.
two different contexts. So he doesn't care what his arguments are. And G is the same value. So the type of this is, I have two types because I'm doing two typing systems here. And here's the first type, which is AB returns a pair of B and B. And what is A? A is the hidden internal display. It's your Clojure. It's your upstack reference. It's a leaf because it's unused in this example. And then there's a flow type, which isn't any more exciting. In fact, I have it very ugly, pretty printed, so I probably won't do it. But it says the same thing. It says I take some arguments and I return a pair. The pair happens to be whatever things I can be passed in from the external world. I do know the difference between internal and external things. So I know for a fact that B can be any external function. So that's an easy one. Mostly it's showing the difference between variables that are not local, let bound or polymorphic. That was the goal of that test.
Your
So
f space 3 and f space string are function application?
Yeah, in AA, I can do function application in two ways. I can do it with function space argument, and I can do it with parens following C style. And in fact, they're ambiguously the same here because every function in AA takes exactly one argument. If it happens to be a tuple, he will syntactically sugar unpack it for you. So a function call this here function f can be done like this. Oh, look, it's a function that's with adjacency being passed one argument, what happens to be a tuple containing a single value 3, syntactic sugar, he unpacks it. It's as if you did a C-style function call.
So if I do that, the internal tuple will not get unpacked because the outside is acting as a tuple.
Yes. You've
And the
just
inside
passed
is a
the
tuple.
tuple
So it
like a
already went
single.
through one layer.
Yeah, exactly. Syntactic sugar unpacks one layer. And tuple is spelled with, LE.
And if I do that instead?
Well, here you're making a struct, which is probably not what you intended. You made a struct, but you didn't define, this is a syntax error. You didn't find a field for the struct. Right, now you pass a single argument, which is a struct. He will not unpack it. You got a single struct.
And is that your plan for named arguments?
I didn't sort it that way. I have some write-ups on named arguments. This probably should go in with the write-up on named arguments. It's a perfectly good way to do named arguments. Now that you've said that, this makes a lot of sense for named arguments.
So
I have a list of to-dos and how to handle things, and named arguments made it somewhere in there.
in this
Yeah,
function,
that's one of the syntax things in Python I can't decide whether I like or not, is that you can pass in positional arguments and then named arguments in the same call. And
Right.
sometimes that seems nice, and sometimes that seems annoying, and I haven't decided yet if I think that was a good or bad idea.
Okay, so what this proposal says is that if you do named arguments, then they don't have positional as well because you don't get the syntactic sugar unpack. But you don't.
I mean,
in
unless your
syntax
struct syntax does that, but
well, he doesn't. He gives you the struct internally. Like I could do struct unpacking explicitly on the F side. Right. So here you've defined an F, but now I mean you made a call to an F, but now I'm define F. So I'm going to go define F here. Somebody's trying to write it too. I'm trying to not collide on it. I'm going to say F is defined to be a function which takes a tuple and does whatever it's going to do. And it's not a tuple, it takes a struct, and now you're named things. And this is just a name unpacking. And all that says there is I have declared the syntax sugar on the F side. He expects a struct and he will unpack it. And then X and Y and T are available in the ... portion without further ado, right? Okay, whoever's writing with quotes around A, that's not valid syntax because that's not a field. What are you trying to accomplish there? Yeah, who's on my screen's anonymous leopard. You never know. Somebody's still typing, and I don't know what they're trying to accomplish. But it's not syntax that I currently accept because I don't do quoted.
Right. I was arguing that you could have sort of default names in the same way that when you make tuples, that's essentially a struct where the names in the struct are just numbers
Oh, I
in
see
order.
what you're trying to do. You can allow to have names. Okay, at the moment, I'm going to say no to that. Under the you would have to have semicolons here because it's a struct syntax. And so I probably got this wrong here. I'm using semicolons for struct syntax. because literally a struct body is a series of statements, and the assignments that you make there become the variables of the struct. So what you're saying is if you don't give a name in a struct, you take the default names. And the default names are in fact 0, 1, 2. Yeah, I don't know.
I mean, it's kind of gross.
Yeah, this is not my current syntax on purpose. Because I allow you to have arbitrary statements in a struct body, they effectively are treated like CL in Java does. Same kind of thing.
Because to some extent, the struct definition is run a thunk and return the namespace when you're done.
Yeah, basically, yeah. The semantically, yeah.
If I don't have the at, then I return the last thing.
If
I do have the at, then I return the namespace.
If you don't have the at, you're defining a function because you have curlies. You have to have round braces. And if you have round,
but my curlies will be a function that will return whatever the last statement is.
Yeah, you can make it some. Yes, I'm sorry.
That's so if I don't have the at, what I get is the last thing.
Yes. Also, if you don't have the
return of the last statement, and if I do have the at, what I get back is instead of the return of the last statement, I get the namespace.
You get the thunk. Yes. Now there is another difference here, in that you can't assign to 0 because I don't do field name 0. So I guess you're trying to do something here.
Yeah, you would have to have some sketchy default name that was like.
Yeah. That's sketchy as well. But you could have argued that there's a very small syntax change to alternate between running a thunk and returning a namespace. That was a fallout of using curlies for both namespace, only for namespaces, which meant it was for structs and for functions. All right, I'm going to grab another example. This one specifically for Alan, and then I'll grab some other examples which are a little more obvious what's going on here. So this guy does exactly what you want. His type is ugly because the pretty printer doesn't print it so pretty. Oops, there it goes. So the type is an A, which is the display, which is the hidden extra variable, which is not present, not used in this example, so it's dead. It's just a leaf. Then the recursive type B, which takes a function f, which has its display, and f again, and returns a D. So it's been unrolled, and you could argue the pretty printer should roll it back up a little bit. There's a re-rolled version of that that's a little tidier, which actually I have lying around here.
Yeah, and what I was arguing on the chat a while ago was that it's already wrong as soon as you introduce the recursive type.
Right.
So
yes.
Obviously,
already immediately several well-known languages like, oh, come on. Sorry. Several well-known languages have flags to turn it on. And then they get the same exact answer I get for the same exact reason.
Right, but that's like saying, if everyone else is doing drugs, then I can too, right?
That's correct. I'm busy doing drugs too. They don't come along and say it's incorrect. They barely come along and say, we can do this, but we don't like it, so it's on a flag.
I mean, that's the entire argument for strangeness budget. If you're the only one in your group of friends who smokes, it's like, oh man, smoking stinks. Go away. But if everyone in your friend group smokes.
Well, but it's not like you have to use it. It's like it fell out for me as an easy part of the whole setup. Like I have to go in right now, I'd have to go in and just deny it because I'm already doing recursive everything. So it's actually, I'm just going to let it fly. If you don't like this code, don't write it. You get an error in other languages. So I claim if I do something reasonable with this and not give an error, I have strictly an improvement over another language which simply errors out on you. And there is the fight between. Okay, let me go pull up more things that are more obvious what the hell they're supposed to be doing that you don't care.
So I was listening to some people complain this week about premature optimization being the root of all evil.
Yep.
And to some extent, a lot of languages are kind of pushing toward premature optimization with things like manage your own memory. I wonder what things you can do in a language that inherently makes it easier to do the sort of quick and dirty early things.
Well, I'm trying to head that way. One of the things you want to do there is to have, same thing with Scala is make DSLs, which is where you get into operator overloading so that you can screw around with things that are more exciting about,
I mean, there's something, I guess my question is I'm trying to reach for what is it about like awk and the dtrace language that people don't save those programs. They write them every time.
Right.
Like there are people who have awk programs saved in a file, but I know a lot of people who will write the same awk program every week for a year and never stick it in a file.
I have saved awk programs.
But it's just like there's something there in awk that makes it very easy to write a quick, dirty program and run it and see if it did what you want.
That's a REPL. You're using the shell as a REPL. You write the awk on the command line with the awk script. You look at the output, you correct. You always made a mistake. You correct yourself and you go again.
But it's still hard to write JavaScript that way.
Yes. Yeah.
Like I wouldn't write JavaScript by just typing it in the command line as a little program.
Maybe it's harder to get a useful web page out of JavaScript. So I bring up the REPL in JavaScript for web pages, but usually only to ask questions from the REPL of what the JavaScript means here. Let me see if there's any more useful examples here that I should pull up as like interesting things. This one's, there are some ones I think would be only surprising if you stare at them. Oh, but here I can pull this one up here. So this is a useful one. Yeah, here's.
So in your example of -,-,-1.
Yes.
If I define a -,-1 operator, how do I know whether I'm going to get?
Hang on. I have a truck rattling around outside, which might be gas.
We lose Cliff?
Oh, yes, no. He went to go deal with a truck that was in his driveway.
Oh. Oh, we could talk about something else, that he's not
in your language. Do you let people have operators that are subparts of other operators? Could I have -1 and -,-1 both defined at the same time so I get this ambiguity that I just highlighted of do I do the single minus thing and then the two minus thing, or the two minus thing?
So my plan is to use like a, generalized LR parser. So like it'll get all the different parses and then it'll just error if it's ambiguous. So the answer is that what you type would be an error, but that if you were clever about it, you might be able to not make it error and have it work out somehow. So, in particular, like if it turns out that the ambiguity check is like at the semantic level. So if like what you wrote, like all the parses parse to the same thing at some level of interpretation,
Yeah, that's fine
then it's fine. Yeah. But like if it's like, you know, I parse it this way, I get 1, I parse it this way, I get 2, you know, then it's an error. So that's, yeah, I don't know.
Which is technically true with floats.
Well, yeah. I mean, there are areas where, you know, it's very hard to avoid getting an error. So
I saw a bug once on a radar system where we had to give the GCC a flag that was like, treat floats as not commutative, because some builds it would commute the floats and some builds it wouldn't, and it was actually changing the output we were getting.
yeah, I mean, what I found, there's like some papers on like automatic reorganization of floating point computations to improve their accuracy. So I was thinking of using that, and like, it rewrite like,
if I have a tiny number plus a giant number minus that same giant number, the tiny number will get swallowed. But if I can reorder it, so I do giant number minus giant number plus tiny number, then the tiny number doesn't get swallowed.
Let me interject real quick here. So the gas man's here. He's filling our tank. He'll be done in 5 minutes. I'm going to go run with him and make sure all our lights are on. Pilot lights are on, and then I'll be back. So I'll be here for 5 minutes, gone for 5, and back.
Okay.
I don't have pre-increment right now. So I probably
I'm
won't.
just saying, if you have both minus and double minus defined, if those are floating around in whatever scope you're in.
Yeah, so the parser says...
Is this just an error at this point?
Right, no, at this point, well, okay, so I don't have pre-decrement. I have post minus minus, not pre. So that is in fact 3 minus signs in a row, unary minus signs in a row. And my test case was simply to ask the parser what would he do. And my theory on it is he will do longest greedy. The other option is shortest greedy.
The most common is the longest matching prefix to be an operator. So
yeah, so right. So I think right now I'm set to do longest greedy, which means that he will take the first.
Okay. There. Now something's defined for that.
Like, right, exactly.
I can make the problem.
Well, you can't right now make an operator in an operator scope. That's not, no, operators have changed since we last talked about operators, right? So right now operators need an overload, and they need to be and they're found by the left-hand side value, unless they're in a prefix position, and they're found on the one right-hand side value. So you have to have a prefix operator. You need to wrap parens around it because he is going to do an overload resolution. But then you can make the problem as long as you put it on the left-hand side of something, or the right-hand side, which would be an int. So you'd have to put that in the int space, which right now I don't have any way to let you add a new operator to the integers. Right, so that
just
that is
doing
a thing
that
I
won't
want
do
to
it.
do, but it's not. There's not a way to add an operator to the integer space namespace, and then you would get this problem. Yeah, and I would grab the first minus.
So it's not enough for me to have this function in the environment. It has to be on the struct.
Yes, the integer class. Yes, I quit doing operator lookups in the global namespace. They are all done because you have to do overload resolution typically. I need one of the arguments to do resolution on. So I demand.
So this is now an error, or this is just now a very confusing function name?
Oh, that'll be an error because you're leading it with minuses, which is not valid for an identifier. And if you flopped it around to be a post increment, I have that one, and I have that problem. Yeah, the point of this one is, what does the parser do, and what do you want it to do, right? And you know, I do have a global list of operator names. So I would parse the 2 dashes as an operator name, go look to see if I have a valid right-hand side and fail. Because I failed on the right-hand side, I would go back and try a fewer characters.
So you're just going for essentially longest string match first from the left.
Yeah. And once I've got an operator, I have to find an expression to the right of it. So
that's at least not ambiguous.
Yeah. I claim
it's potentially confusing, but it's not ambiguous.
Well, you were at 3 dashes in a row, you expect confusion. I mean, this is like this is like obfuscated C club, right? I mean, I'm exactly trying to bang the parser on the head and make them get confused, right? Or write ambiguous something, and don't write that code, right? That's the easy answer. What did you intend there?
I mean, that's usually been my answer when I confuse myself with order of operations. Is eventually I'm just like, you know what, parentheses everywhere until the bug goes away.
They work. That's right. Exactly.
And I've got a lot of lines where my IDE is like unnecessary parentheses. And I'm like, no, because I had a bug. And now I'm leaving these parentheses
and therefore they are necessary for my clarification. That's correct. Yeah, there's an ongoing debate in my head about whether or and should demand parens if you put them in the same expression. Like if you go to the land of C, there's a clear order. I think there's a clear order in the land of Java as well. Nonetheless, I find mixing ors and complicated if expressions to be like confusing and need parens. Okay, this is my gas man. I have to go talk to him. So I'll be back in 5.
Yeah, I feel like or and not should all be at the same level. Whether that means you have to have parentheses or whether that means left to right. Having either ors or ands be stronger binding feels wrong.
It's going to be wrong half the time.
It's like multiply and divide, where it's like, they're the same level of binding strength, so you just go from one side to the other, but often when I'm doing divides, I end up putting in parentheses I don't need just because for my brain, I want to know what's on the top and what's on the bottom.
Yeah.
Derek, you've written a lot of Clojure, right?
Yeah. I'm that's my main driver, my daily driver.
How often do you find you are bit by the fact that Clojure will swap out the underlying class for you some of the time? So if I make an associative array that's got less than 32 items in it, I get an array and it iterates the array the whole time. And once I get to larger size things, it's like, oh, let me swap that out for dictionary under the hood without you noticing.
Never. That never bites me. It's totally transparent because I don't address the objects by their type. And I'm not calling type methods on them. I'm using the Clojure standard library, which works transparently the same with all of them. It can bite me in very specific situation, which is a different one, which is if I create a def record. I don't know if you're familiar with those. So a def record is kind of like I
thought it was like a struct.
It's kind of like a struct. It's kind of like a lightweight type or something, but it's map based. So you can do map operations on it, it's a struct pretending to be a dict. It's a dict pretending to be a struct. Well, it's not. I think it's not pretending. Like the fields that you give it are, you can use like dot. You can use actual property accessors on them. But then it's open to other data being added, which is fine, and it retains its type if you add random stuff to it, which can be handy, right? So you get someone else's def record and you want to stick your own field onto it, you just stick it on and that's it, and you can iterate through the keys, and that way it acts like a map. And unlike JavaScript, where you can iterate through the fields in an object, but it also has random other stuff you don't want mixed in. It just has your actual data. So that part's okay. But if you dissociate a field from the def record, like for instance, well, in my sea of nodes implementation, I use def records for the node. And sometimes I will attach or detach a pin to a region. So I attach the pin, I just associate in the ID of the region that I'm attaching to. If I dissociate that region from the def record, it turns into a plain map and everything will start breaking. So for that specific case, the predefined fields for a def record, I have to make sure I associate them to null, which I would never otherwise do.
Because you can set them to null, but you can't set them to nothing because they're a place, and that's place-oriented programming.
If I make them nothing, it changes the type. So that's the only gotcha that I ever hit with that type of stuff. And you can tell it took enough explaining that it's not probably something too many people
that you run into all the time.
But I like def records. They're handy because they have like a kind of very convenient overall interface. But that's one thing that's just, it gets me virtually every time I use def records in a larger project. But I'm familiar with it now, so it's just one of the gotchas you deal with.
I always like the idea of null and zero being different, because sometimes you want the default value and sometimes you want null or not available.
Yeah, this is not exactly, this is, yes, I agree with that, but that's not what this is. This is, if you dissociate a key from a struct.
Right, it's the distinction between null and not present.
Yeah, it's not present at all, or it's.
Oh, I see.
Yeah. So normally with a map, once you're done with a key value pair in the map, you just remove the whole key value pair from the map. It's just a weird special case that for the built-in.
JavaScript dealt with this by introducing undefined to be, this is the actual value that means not present in any variable that is not currently defined. You can so
look
up anyway, and it will just be undefined. You're like,
yeah. And
okay.
The thing is that you can do it. Like everything works. The only thing that breaks is that your def record stops being a def record. It starts being a regular map. So so if you have, like, you can attach additional protocols or interfaces onto the def record. So I have my record type, and I can have like some special functionality on it, so I can that's usually why I would create a def record versus a map. So then what'll happen is that everything will work for a while because mostly everything works the same. And then suddenly later on, it'll be like, oh, my def, why is this a map? It's not a def record. And then I have to go searching around for where I did a dissoc on it, because it's the only case that I know of that causes this problem. So
C operator overloads or precedents are not intuitive. Cliff said it was easy a moment ago, or I might have misstarted.
I'm back if you wanted to ask me directly. And
not easy. He said it was defined.
Which one are you talking about?
The binding strength of C.
I said C operator precedents are horrible.
I've lived with them all my life, so I know what they are. And
the and thing annoys me so much, and so does or not being higher precedence. I prefer my or to be higher than and.
Yeah, and then Java copied it verbatim, even though in the design notes they said, we probably should change these because they didn't really make sense even for C. They definitely don't make sense for Java, but we're in a hurry, so.
Right. Before I left, I said I was in mental debate of whether or not I was going to force parens if you mixed ors and ands in the same expression, declare a syntax error and demand parens.
I do that actually. Logical ands and ors. If you put them in the same statements, it just throws an error.
Yeah, I think that's entirely fair. And I might go the same route. So that's Levo.
The ones I
Yes.
accept just because every high schooler had to learn them was the like multiply being higher precedence than plus.
Yeah, right. Yeah,
There's
yeah.
a language, I can't remember which one. It defines basically only two levels of custom operators, the addition level and the multiplication level. And then it predefines giant blocks of Unicode characters that you can use for them. I guess in any combination, I don't know.
So it's like a smiley add or multiply level.
No, it's so Unicode has math symbols as a.
All right.
I can't remember. So it's legit. It was well thought out, and I've never been able to find it again after Guy Steele sent it to me. I think it was Guy that's like, he's like, you should look at this, and then I've lost the link somehow.
That sounds like something Guy Steele would enjoy.
Yeah, he's still a kid when it comes to languages.
Yeah.
I really enjoyed his talk on, I think he called them fronds, the bushy data set where you have like a lazy map of lazy maps of lazy maps and you're trying to explore the thing. And it's like you want to totally randomly pick a place and make some progress and then pick a different place and make some progress because it's quite possibly got a bunch of different infinite chains in it, but you don't want to get stuck in any of the infinite chains.
So I threw two more examples in. One of them is just mutual co-recursion works. That's forward references are automatically picked up and do the right thing. And the last one is picking an operator directly as an overload. So you pick up one of two different overloads. The dot underscore is overload resolution on an overload. And that works in all contexts for you. It's a field lookup where I'll name the field for you. I'll infer the field name. So the under plus under and the under times under are the two primitives. And they'll do int plus int or int plus string or int plus float or whatever your primitives do. And same for the multiply. And then I'll pick the correct one and apply a 3 to it. And that's what that expression's doing.
But when you're picking the operator like this, it has to be in the sort of typical function position, not like.
Yeah. So operators in operator position, I do all the lookups and the syntactic sugar you're seeing here for you, throw it all into IR, but you can manually write it. Oh, I see. Here's the operator table. Hey, Lebo, you can put those kind of things in the Google Docs if you want. It's fine. But yes, but if you want to just talk about an operator as a first class function, it's officially, actually, it's just a field name in the integer class. So the 2 is integer. You do a field lookup on a 2, it looks in the integer class. It finds a field called under plus under. That field contains a tuple of choices, standard normal tuple, and then the multiply does as well. Now I have 2 tuples. They happen to be aligned in terms of their size in fields, or I would have given you an error already. Now I'm going to pick which one. And they're both sets of functions which take always the 2 on the left-hand side, but something else on the right-hand side. In this case, I hand you a 3. So he picks between 2 plus 3 and 2 times 3. And so that expression is the result of 2 plus 3 or 2 times 3 based on a random number. So it's an int. You know, it's either 5 or 6. So he just tells you you're an int. But that was me breaking out how I deal with operators and got that working in the main code base.
So what is the dot underscore on its own there? Sorry.
That is a field lookup where I'm going to infer the field name. So let me break those apart into a little more bits here. So I'm going to declare plus to be 1. Whoops, what the hell did I do here? I hit something to shrink the size or something. Okay. So this will be all the ways to add 1 to something. which would be, 1 plus int or 1 plus float, whatever float I can type, or 1 plus, string, or whatever you want to have for your primitives. That is actually typed as an overload, which is actually just a tuple of functions of 1 and an x2, and then the primitive, whatever it does, and function 1 and the other primitive, and whatever that does as a tuple. And tuples have field names 0, 1, 2, 3, 4, 5. So this could be x as an int here, sorry, and this would be y as a float, and so on and so forth.
So do you do tuples like a lot of languages where you've got tuple 3, tuple 4, and then you stop at some arbitrary number like 14?
No. As long as you keep adding values, I'll just keep letting you have more fields called 1, 2, 3, 4 up to.
I saw you smiling, Theodore, so you know what I'm talking about.
Yep. I know what you're talking about. And no, the parser doesn't care a whit. He just parses a field and adds a +1 to the field number.
But testing, you keep appending the overloads as a next function and resolution. Doesn't this testing for resolution grows linearly, or maybe not? My point being, if you add too much overloads, that would mess up overall resolution. It will. So
my current theory is
because you have to test. You have to test from left to right each type. Does you resolve?
I test from Hindley-Milner's most well-defined to least well-defined.
Okay.
Once somebody is defined, he resolves. That typically will let you resolve the next guy. If there's no one who can be first resolved, then it'll be an error. It'll be ambiguous error. So it is not the case that you can have multiple parallel convenient resolutions. If I only were to pick float here, then everything would be a float. And if only I were to pick complex here, everything would be a complex. That can't happen. Somebody has to be the first driver that forces you, and then everyone else is inferred directly from that. And that's on purpose to prevent sort of weird ambiguity choices. I can always look and see, and here, right there, I have to be a complex, just must. Okay, now that I have to be a complex here, this has to be complex, this and this and this and blah, 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 and you sort it out from there.
My point being that it will increase the time for the resolution, because here that the possible overload resolution grows, and for each resolution you have to test all the you try the first one, then you try the second one.
It's linear in the count of choices in the overload field, yes. And the retry happens every time one of the types internal to the overload sharpens some more until I get a fixed answer. For things that look like primitives, they'll sharpen exactly once from a leaf to an int, and you're done. If you have your own handmade overloads where you have very complicated types and you have a bunch of choices, you'll get a number of times through according to the number of times I have to sharpen your value and the number of overloads in there. So it's basically linear in the size of your program still.
If you involve another overload, doesn't that will get the picture more complicated? Because you have
not algorithmically more complicated, because this goes to incremental Hindley-Milner. If you're not making a change, I don't do anything. It costs me nothing. When somebody changes, I'll go revisit his neighbors, including the overload. Now the overload resolves because one of his fields sharpened to the point where that's the only valid choice. Because that one sharpened, his neighbor now sharpens.
Okay. If you have two overloads, the first that would fit, that would cause the resolve, it will fix to that type, and you have to find the suitable next door, the second overload. You have to be suitable.
Squared. Right. I visit everybody once, and then everyone tries as hard as they can, and they quit when they can't go any further, and they're put off to the side. But somebody made progress at the end, and then I pull some guy I didn't finish the job on, I go back to him, and that's incremental, right? Yeah.
So if I have one implementation of my function that takes int64 and one that takes float.
Yeah.
And at the specific call site, I've got some int53 that is both an int64 and a float, or int32, if that sounds better. How does it decide whether to call the 64-bit version or the float version?
It shouldn't, at least in my opinion.
Right. It won't. It'll say ambiguous.
Okay, so it'll say at this particular moment, I could promote you either to a float or an int64.
Yeah, right.
Pick one.
Right. The rule is
add some code. You need a cast here.
I'm sorry?
So it's add some code. You need a cast here.
Yeah, right.
Or annotate.
Or the cast is an annotation. Yeah, right. The rule is I have to have one unambiguous or you're not resolved yet.
One best unambiguous.
One unambiguous, however you define ambiguous. So in the case of the ints and floats and the guys coming in with a smaller flavored int that fits into the float semantics, then you could argue there's a best, but I'm not right now. At the moment, I'm in the zone of it's not. I could be an int, I could be a float. I'm not doing a best guess. We're done here. You're ambiguous. And that kind of goes around to the whole usability of these kinds of things. If there's no choice, if it's obvious, then it's unambiguous in my head as well. If I say it's int 53 and I go through a multiply operator, the result is no longer int 53. I don't know what size the result is, but it could be as big as int 104, 106, or whatever the hell, right? So at that point, I'm going to be ambiguous at the next step. I guess I would be unambiguously ints, and so I don't know. I'm not going to play the int float game with smaller Boolean things on overloads right now. We might get there, but I'm thinking no. Unless I can prove the result, like the int guy produces an int result, but I don't have an int 53 guy producing an int 53 result. So if you put an int 53 in on an add, your result is going to be int 64 or float 64, and that'll resolve everyone else after that. Maybe it's sane. Maybe I could go there. It's one of those. I'll get to it when I get to it. The best heuristic right now is simply
the fact that every time you add two numbers, you have one more bit, and every time you multiply them, you have the sum of the bits.
Yeah, right.
Feels like we still don't have the right answer from programming languages.
Well, the answer is you're either doing fixed point math, and you know that it will never overflow because you've range checked it manually yourself, or you have big numbers like 64 bits, which don't overflow unless you pretty much know that you're doing stupidly large things, and then you need to pay attention again, right?
Yeah, that's one of the few places where I disagree with AA, where you start with the rollover modulus ints. If I just type 5, I have said 64-bit rollover int, probably.
Yeah, that's my current theory. That is
whereas I feel like the default I just typed a number should be a checked int that throws an error if it rolls over.
Yeah, but AA is not a language for checked ints by default. Like Cliff is at least being consistent. Like you may disagree with him, but he's highly consistent in his preferences.
There you go. I could go to a spot where you can ask for some sort of checked int. And the integer primitive, constant propagation math is done perfectly with full precision. So there's no wrap or rollover on constant propagation.
I showed like a year ago how we did the checked int. So that's our default is checked, and then you can say
and you ask
unchecked.
For the wrapping int.
So you can ask an int. So you can specify unchecked as a mix-in into int, and that makes it an unchecked int. And int always has 2 checked and 2 unchecked, so you can always convert it. But obviously, unchecked from a C point of view is dramatically simpler and better. From code gen point of view, from a performance point of view, etc. I mean, it only matters when your rocket crashes, right? So,
yeah, and people who do rockets probably actually are willing to specify, I want to do range check math.
Right. Or have some other means of verification. Right.
Honestly, you have to be a little more careful there. when the rocket launches, if you throw the rain tracks, you still crash. So instead, in testing, you want the overflow checking. But when you go to production, you don't. You want best effort, keep this fucker flying. Sorry, keep this thing flying. And if the overflow was not fatal, then it kept flying, and I'm okay.
I like your apology, like Tidor sitting there, like, okay, mute the last 5 seconds, beep it out.
I was going to say, does the software you use to process the video even let you bleep out a second?
Yeah, it's YouTube. It's a pain in the neck, and it's totally doable. And maybe you don't know this. I have been requested and done so already several times. And a person whose name I shall not mention accidentally let some of his work notifications pop up and get recorded, and he did not want them recorded. So I edited them out.
I thought you were talking about bleeping out my cursing.
I'm not bothering with that. No,
thank you.
I think there's no tender ears here.
I completely agree with int overflow. I was considering doing the same for my language. I just think that most people, if they assume there's no overflowing, they're not going to try to make a best effort to keep it going. So I had to consciously think about it when I write my code, if I wanted to keep going.
You want it to, oh yeah. I've done lots and lots of stuff with like big data, which turns into big numbers, which turns into things that overflow. So a lot of conscious thinking about this will or will not overflow. Also, floating point math is not math. It has its own approximation rules. And so there's a lot of numerical stability went into a lot of those algorithms. I don't know if that's a common way for other people to think about them, but if you add a billion numbers and they're all tiny, then they all, and you start with the biggest number, all the tiny ones underflow and wrap away and disappear and add to nothing. But if you have a billion of them and they would have added to something, but you added them away in floating point, they add to nothing, and you lost a giant amount of end result. The higher order bit can be wrong because you rounded off in the wrong
That's
order.
why we default to float 512.
Yeah, but Cameron, I said billion, trillion. It doesn't matter how many bits you picked. I'm going to overflow, underflow, and you're dead unless you have a numerically stable algorithm.
There was a fun demo one of my compiler professors used to do where you would generate a billion floating point numbers randomly between 0 and 1.
Yeah.
And if you added them from largest to smallest, or you added them from smallest to largest, and you would see how far apart the numbers were if you sorted them and then added them in opposite directions.
You get, yes. And I'm just saying, it doesn't matter 512, 500,000, 5 million bits. It doesn't matter. There is a larger amount of numbers to add, which will force that to be dramatically wrong. High order bit, random, basically, unless you use a numerically stable adding.
If you have an int 64 and you're just adding a bunch of columns, like a sum,
yeah,
how many columns would you guys estimate until it starts overflowing? Because I had I think 100 million and it was fine. But 100 million, I don't know if I should be nervous.
No, that's the wrong way to think about the problem. It'll overflow with 2, or it'll never overflow with an infinite number, depending on what's in those columns. So I don't play the game of what do I think. I have to know something about the range of values I'm adding. Right? If I'm adding people's children, I think N64 will cover the entire planet. If I'm adding people's income values or valuations, well, Bill Gates will blow me out in 1.
Not in 64, but
like blow out in 32.
In 32, yeah.
Okay, maybe in 32. But if you add, the point being, if you add up the wrong kind of things in the wrong order, you'll blow out. And so you know something about the scale of values you're looking at if you're trying to not die that way. Yeah, Matt's correct as well. Right. As soon as somebody has a big number and +1 and you blow out, fine.
But yeah, I do find that I've hit 4 billion a lot more often than I hit 16 billion.
Yes.
Yeah.
Yes. When I was a younger guy, N32 was enormous and we never, ever touched it. Now, last in startups I did, of course you blew out N32, but N64 is still hard to blow out unless you're dealing with like unscaled numbers.
We used to have to write libraries to do 32-bit math because there were no instructions for it.
Well, we did add with carry.
I think Twitter couldn't use floats for numbers anymore because I think it was like 48 bits was just not enough.
Yeah.
I don't know if they have that many tweets, but because they might have gaps in between numbers for sharding reasons.
Yeah.
But yeah, they can use
There are not 2 to the 53 tweets. It's the fact is the tweet ID is largely a timestamp of microseconds since 1970.
Yeah.
And there are that many microseconds since 1970.
I thought there were that many bots.
But I do recommend reading the Twitter Snowflake. Here's how to make globally unique timestamps.
Yeah. Oh,
it's a nice, short, easy to read.
I did the whole fintech thing, which were all about timestamps. And some people did, millisecond times, and some people did nanos with some more bits, and some people did 2 sets, one with millis and one at nanos, and they weren't exactly aligned. So you had to screw around and you had to add them and shift and some more screw around. And everyone fucked up time zones. So that was always, never mind. Time is its own special snowflake right away.
Yeah, but the nice thing about financial services is that they don't run over midnight for most of them. So you get this wonderful aspect of time zones where you don't ever have to deal with leap second.
Yeah.
Because you're always running in a zone, if you will, that has no leap second.
They do run overnight relative to each other. But yeah, at any one point. We were looking for a fraud between, logs from different exchanges where people were whitewashing or whatever, wash trading across exchanges, which means you had to align the data between 2 different exchanges.
So my guess is the reason that we have no 24-hour exchanges that are kind of standardized around the world is because of time zones. Like that's probably one reason. Like there's no one in financial services smart enough to figure out time zones.
There's a couple other reasons. There's like end of day events. Everyone has an end of day event.
By the way, /s.
Currency traders go 24 hours. And
crypto. Crypto's 24/7. Yeah.
Yeah, I learned about the 24-hour nature of currency exchanges when a friend of mine got way too high and then lost all his money.
Crypto
like 20 years ago.
Crypto is not 24/7 because they often take it down for maintenance. So literally, like the Coinbase was down the other day for like 4 hours for scheduled maintenance or something.
Yeah, but their intention is to run 24/7. They haven't got that old IBM 5.9s reliability by a long shot.
That was one of those funny moments when YouTube used to just lock all rights to YouTube during leap seconds because they decided not that they had a leap second bug, but that it was cheaper to lock all rights during the leap second than even try and figure out if there was a problem with the leap second in the YouTube code base.
Yeah, I can buy that. I can buy that.
They're like, you know what? You're just going to have to upload your video a third of a second later because for this third of a second, we're locked.
I thought leap seconds were handled by like an internal clock skewing how long a second is.
No,
that's what they do now, is they smear the leap second across an entire 24-hour period.
It depends on the time zone. So, and it depends on the operating system. And
let's say the exchanges do not do any sort of time smear in game.
So Unix just ignores it, which I think is actually the best answer. They're like, we'll just assume it's 24 hours a day, 60 minutes an hour, 60 seconds a minute.
And what's your mean time?
If there's a leap second, you can go back and factor it in if you want to, but this server is going to get rebooted in the next 10 years anyway. So it's at least a second off. And, and it's a very practical decision. And then
NTP does something. I thought that you're talking about the streaming. That's NTP.
No, I'm talking Unix.
Yeah, right. Oh, Unix.
Unix with a big UNIX. Yeah.
Gotcha.
And I think Linux may have copied it. I can't remember.
I thought Linux.
Yeah. So UTC-1 doesn't do the time, doesn't do the leap seconds, but UTC does do the leap seconds.
What leap seconds are caused by is the difference, the delta between the atomic clock and the star clock. So basically, the British always kept time by the stars. And then in 1938 or whatever, they introduced the atomic time, and then it diverged. And then it can diverge in either, like it's not a it's not a fixed divergence. It actually oscillates.
Go read up on these things. I've done that. It's kind of fun.
It's crazy.
Yeah. All right. Are we done with astrophysics here?
Sorry, I interrupted Aaron, I think so.
Next topic.
I was just going to make the comment that most of the distros have decided that they're not going to deal with the leap seconds because NTP does clock speed up, slow down tricks to get in sync. So if you just let the people who are super serious about time deal with the leap second, and your server will just sort of slowly drift back into compliance after the leap second happens. Which I thought was a clever trick of just don't.
I'm going to claim the AA update is done unless somebody else has. Anybody else have another AA question about overloads or anything? I'm going to be done.
My question was about APIs that have different implementations under them where the developer doesn't care. So we're talking a little bit earlier about Clojure, where Clojure has their map interface and most of their functions take and give the map interface. And when you first create a map, if it's got less than 32 items in it, then it's going to implement that with an array. And eventually, once you get to a big enough map, it's like, okay, now I'm going to put a hash table under it instead of just an array to search the whole thing. And that happens very transparently. I think most developers who use Clojure don't even know that at some size, they get an array swapped out for a hash table under them, and they don't care. What do you need in a language to make that function nicely? Is that just in the standard library, I'm sticking a thing into a map, or?
Yeah, right. Map call around something, and then you don't care how the map's implemented.
Yeah, I think the Clojure people, they didn't have the protocols idea at first, and then it was added. And I think there's a bit of regret that it's too hard to go back and retrofit the data structures to use the protocol thing. But it all works with the sort of I don't know how they did it, basically, the method.
I mean, they did it with assoc just return. Assoc is not guaranteed to return the same type that you passed it.
Yeah.
You can be like, here is my map, add one thing to it, and give me back a new thing.
Why is
that? And they have a kind of complex set of interfaces and stuff that are used in the implementation, and then the newer implementations like Clojure script use protocols which simplify the interface story a little bit, I think.
But why is the type changing if my hash table moves from a table to one kind of an array to another or whatever?
The way they implement it is that there's an immutable hash map and an immutable array map class type, and then it just returns a different type.
Okay, so they don't have a immutable hash table whose implementation of the hood is either an immutable array or an immutable. Okay, I see.
Yeah,
right. But if you have a full array and you add one thing to it, it's going to be like, here is a hash.
So non-blocking hash map is always an array, but the starting size is two elements.
And then immutable ones are not immutable.
As soon as you get to the third, it grows to the next size up, and it's just an array, basically. But I keep adding new arrays if you keep growing. All right. I didn't understand that you actually switched the implementation at the user visible level as opposed to just slid it under the hood.
It's user visible, although I think, so it can be there can be a bit of trickiness if you're, for some reason, checking the actual Java type of objects, but Clojure gives you standard library methods that do this pretty nicely. So I wouldn't do, type is a, hash map. I would do, the map ? function, which does whatever test it does.
Right. You want to ask implements questions, not what exact type is this thing questions.
Well, so why do you care about an implement? Oh, you want an interface? Yeah, want an interface question. Is this guy have the hashable interface or the hash map interface?
Yeah, exactly.
Yeah.
But it can be slightly annoying because, there's this data type called records in Clojure, which I was talking about one aspect of it before, but the one annoying thing about that type is, which is very convenient in general, is that it answers true if you ask it if it's a map. So you create a def record of, you know, a node. For instance, I use def records in my sea of nodes implementation for each node. And so you know, I've hit once or twice where I was looking for maps, and sometimes I had nodes, and I checked map, and I forgot that, oh, my nodes will actually say that they're maps as well. Which they are, like they behave like maps, but they're not. For my purposes, they're not the same as maps.
Why would you ask your interface for a specific implementation? That's
well, because I think I was looking for, in that case, I was looking for maps and trying to pull them out.
It goes against the idea.
I had to change it to say, I'm looking for not nodes, right? I had a predicate for my node type. If
you're able to ask your implementation for a specific, your interface for a specific implementation, I believe it goes against the idea of an interface. If you are able to ask questions about how you are implemented.
Yeah, to some extent, you did that to yourself at that point. If you ask your interface implementation what kind of implementation it is, well, congratulations, you're now an implementation-dependent piece of code.
Why do you want interface?
You decided to ask about the implementation.
The thing is that it's a bit counterintuitive to think that my node record type is actually a map, and it's something I have to remind myself of, because I'm basically, you know, I'm basically, you know, you often pass maps around to for supplemental data or whatever. You're passing maps around for whatever reason, and in some case, I was, you know, I can't remember why, but I had a collection of things, and there were some nodes and there were some maps, and I wanted the maps.
And you had nodes and maps mixed together.
And they mixed together. So I was like, oh yeah, okay, I should do that a different way.
Yeah. Like say, I'm thinking, you know, my maps or my nodes are in fact a map, but it's from the node index. So it's really an array to another node. Yeah. And then the reverse direction is just a set of values.
Yeah.
And both of which I could put a more official API on, and both of which, when I did them in C2, I did all kinds of much tidier memory things for speed, which I'll probably do someday on this stuff. But right now I'm using
Oh, by the way, I finally got rid of the whole exponential part of the compiler, and actually got my queues in order, and I put a queue checker in, and it was nice. Actually, it didn't take that long, and it's much cleaner, and the compiler is way faster now, about 20 times faster.
Congratulations.
Thanks.
All right, don't do exponential things for the win.
Well, yeah, I mean, the exponential was good, you know, for early development, but started getting slow, and it's like, okay, I got to actually put the effort in, do it a little bit.
Mine has the sort of reverse problem. I put a lot of effort in to make it go fast, and then every now and then I creep in an n-squared algorithm by mistake, and it lives on for a while, and then I suddenly realize that, wait a second, and then I go back, oh, this incremental thingy I did actually triggers this other thing, and now suddenly I've gone exponential or n-squared or cubed or whatever.
You write your code
do you have any tests
too high
that
performance,
just like
your exponential things aren't noticeable for a while, and then they're really baked in by the time you realize you need to fix them.
And when you realize, yes, exactly. Because all my tests are tiny, because that's the state of the implementation.
Yeah, that was going to be my question is, do you have tests that are like, do the tiny version of the thing, now do it 2 times, 4 times, 8 times, 16 times?
I have only...
Am I seeing a linear graph here?
I only have a handful of those. And the issue is that you get these things from a lot of different places. So it's sort of it's not helpful to say, add 2 numbers, add them twice, add them 8, 16, 32 times, because the add code and the roll up on the add code is all linear and all works. But it turns out that the if code doing if expressions and merging is screwed up, and you get to whatever, right? You get it there, or you get somewhere else. The last go around is I'm trying to be incremental on my Hindley-Milner, and so I have to have a funny, non-obvious dependency check between 2 different things. That if this guy changes, that guy has to change. And when I was going to set saying, oh, I depend on that type, I was walking the entire contents of whatever that type over there was. And when that type was tiny, I didn't care. When that type was something larger, suddenly every time this thing did anything, he said, oh, I depend on, and he walked an entire large structure over there, and that blew out really quick.
I know it's fun, but is there a reason why you're doing your code gen?
Why am I doing code gen?
Yeah, like why you're not using like TCC or like LLVM to handle it? Right. It sounds like a lot of work, but I know it's fun. So
there's some history here for you. So I did the core guts of the hotspot JIT compiler, which let me skip the parsing, except I started from parsing bytecodes, but I emit code that's 100 times faster than GCC, 1,000 times faster. It's like usually faster at about -02 level. And
faster compile time, not faster code.
Yeah, faster code, 100 times faster code generation. Yes, that's correct. I'm sorry. And the code quality is about -02. And it's compatible with garbage collection, which requires you to track oops exactly. And it allows you to debug on the fly because it retains precise debug info despite being -02 optimized. And you can add new code, which invalidates all kinds of other things and roll back and recompile and JIT and rejit. So it has a bunch of features that are not available in TCC, GCC, LLVM. In the generated code, it's also faster. So, I'm sorry, go ahead.
That's a lot of ends.
Yes, this is why I'm here. This is what got me famous. Okay, so having said that, I know how to generate code. I know how to generate it fast. I am now not generating any code at all. I am simply trying to type. So I'm learning about some kind of really, I've gone way overboard on doing fancy schmancy typing games on a new language that I'm trying to put together. The language looks cool to me. I got hung up saying, what's the semantics of this? Oh, it needs to have the type. So I need my types. And then my types got fancy, and then it got hard for being, research topics on types. So the last 2 years have been research on types.
My type system has definitely been like the top 2 hardest things I had to deal with in this.
There you go.
Yeah. Well,
types. See, now I'm curious what the other one is.
Code gen, the backend. When you can't do a printf because your assembly crashes on right on startup, you have no idea what's wrong. You have to actually look at the assembly.
Yes. So I spent many, many decades looking at the assembly out of compilers, and got pretty good at that. It's really stupid, but I can look at LLVM emitted assembly and reverse it back to Julia code almost without any experience on either Julia or LLVM. Because I did that for that crazy startup. Was like, why does your code suck so bad? Oh, it's because they're doing this stupid thing and that stupid thing. And LLVM was doing stupid shit because LLVM's not a JIT. So Julia was treating it like a JIT. LLVM's not a JIT. It did all kinds of stupid things. And I could just read it out.
I started looking at my C backend, and since LLVM is SSA form, my C generation used mostly SSA form. So I have a lot of temporary variables, and I'm like looking at it, and I'm like, this is kind of hideous.
You might
I understand why it's like that, but it's.
You might look at the Sea of Nodes videos that are on here, and somebody can probably drag them up maybe. I use a thing called Sea of Nodes for the IR. It's SSA all the time. And I go straight to CodeGen from it. I don't ever come out of SSA form in CodeGen. And it's very fast and very easy to do optimizations with. And it's actually fast and easy to do CodeGen with.
Oh, I'm not touching optimizations. I'm just debugging the C code.
I can put the one that you did at DevVox Ukraine. I actually really like that one because it turned out the audience seemed to know nothing about compilers. So you really explain stuff.
Oh, now I'm curious.
I'll throw it in.
It was fun too.
What's that?
And then of course, I may never get back to Ukraine. That sucks.
Yeah.
They want me to talk again, and I just don't like doing remote talks. I want to do it in person.
Yeah.
Fine. All right, that's
notwithstanding spending hours effectively giving a remote talk every week.
I'm sorry, who did?
I said you spend hours doing remote talking about compilers every week.
Which is a very different experience because I see your faces and we go back and forth. When I talk to an audience, I get that feedback from looking at the audience. But if I look at a camera and I'm just recording my face, talking to the wall, no feedback. It just sucks. I can't get any sense that the audience is following or not, or if I slow down or speed up, they're bored, they're, whatever, all those things. Can't do it. A lot of nods from people who've done talks before in public. It's so much nicer to have an audience.
I always hated that moment in university when you get to the end of something and there are no questions and you're like, well, this was either way too easy and everyone's bored or way too hard and everyone's lost and I don't even know which.
And you don't know which one it is.
It's also really hard to tell a joke when everyone's on mute.
So the weird one is in Japan, it's often done that you speak and then the interpreter speaks. So you have to chop your stuff into 7-second bites.
I've done that. Yeah.
So you tell a joke in 14 pieces, right? Each of which is translated, and then they only laugh like 7 seconds after you. Well, actually, in the Japanese is usually 2 or 3 times longer than the English. So you say, "Yes, my name is Cameron," and then the translator talks for literally 35 seconds, and you're like, is she saying I'm an axe murderer? I don't know. Like, so, but it's even worse when you do it over Zoom.
With a translator over Zoom.
Exactly. That's what I mean.
I have not done that. Wow. Okay.
I thought translators could talk while you're talking, and
no, that's usually done after the fact. They'll splice the video together to make it look like that, but it's very rarely done that way live.
Yeah.
I could have sworn I saw that live, but
if you did, they probably actually had the full speech beforehand, pre-translated, so that they could actually go along with it.
Yeah, the UN does that. Every once in a while, the translations will not quite match what the person said because the translator is reading a translation of the written version.
Written thing, yeah.
Interesting.
Which is probably fine. It's probably the better speech.
There was that thing that happened a few years ago with the sign language translation. And the person didn't actually know sign language. They were just sort of faking it.
Really?
They were just doing a lot of stuff that looked kind of like sign language.
So, and the other one is it
happened a few times.
The ancient Irish Wikipedia. So it's in this ancient Irish dialect, but the guy didn't speak Irish, so he just made the whole thing up. But he painstakingly translated all this stuff into a non-existent language, and it like was there for years, and people were like, "What?"
Wow.
I'll see if I can find a link. I think it was like NPR or something covered it.
Wow.
Is there Wikipedia in other artificial languages?
Probably.
They're like Elvish Wikipedia or Klingon Wikipedia or Esperanto Wikipedia.
Yeah, it'd be Dwarfish and Elfish and Klingon would be the obvious, you'll get people doing that. All right, we got something with compilers, language translation of another sort.
I have one other thing that it's not a big update, but I had been sort of stuck for a while on this all state translation thing where I was merging in to all state, which was fine for made building simple, but I was really struggling to sort of unzip all those things correctly. I finally declared bankruptcy on that. 2 days later, I had a working implementation like far simpler. And now I'm finally able to move on and with my life. So kind of happy about that. And, I kind of went with, tried to go with the simplest thing that could work. So I realized that a simple analysis before I start building, and I can know what all my states that I'm going to use are going to be, and I just attach them to every function. And so there's a lot of extra crap in the graph before I start compiling, but it all goes away in about 300 or 400 very simple polls.
Yeah.
And so, that it's about the same amount of work, but it's so much simpler and it's way less code. It's like about 1,000 lines less code. And I'm very happy that I did that. So that's the other thing. So I'm actually have not all the optimizations I want to do built, but I have enough that I'm happy. My sort of 2 flavors of the world, the risk world and the PE array worlds, sort themselves out correctly, and I'm doing backend code gen now. So basically my last step is figuring out how to register allocate.
I have stickers again.
Ooh.
If people want stickers. I guess I should announce in Discord.
How do we get stickers?
I think you send me, because I don't want a deal. You send me a self-addressed stamped envelope. I throw a sticker in, probably 5 or something, and then I throw it in the mail.
Self-addressed stamped envelope. I haven't done that for a while.
Yeah.
Okay.
Remember Sassy?
As seen on TV.
Yeah. I mean, I think I got a lot of floppy disks when I was a teenager that way.
Exactly. It's a physical thing. I can't push it through the Discord video. You actually have to send it. Somebody has to walk the streets and deliver it.
I think that's how I got the first copy of Doom I ever played, was sending someone a self-addressed stamped envelope with cash.
I think Cliff has a big enough
They
place
send back
we
a
should
floppy.
just do a big meetup at his house.
You want to do that? You're going to have some airline tickets for some of these folks.
I will have to fly 9,000 kilometers or something.
It's worth the trip, really.
Yeah, you invited me, so sometime in the future I will visit.
Yeah, come. Yeah. I have a nice place.
I may see you at Crete. They've been trying to get me there for 15 years, and I'm actually going this year, probably.
Where are you going?
JCrate.
Oh yeah, dude. It's going to be hot because it's Crete, but it's a really fun conference.
Mm-hmm.
It's a
Which
casual.
conference?
Never mind. It's fun.
It's an invitation only.
It's invitation only. I'm sorry. That's why I shut up as quick as I did.
It's not really. It's kind of half open.
Half open.
One of the guys who frequents this meeting is one of the organizers there. So
they look for people who are sane and have done cool things, and so you get a well-picked audience.
Right. It's run by Heinz Kibbutz.
Yeah, and pretty much everyone gets a chance to talk. You're not quite forced to, but it's difficult to dodge talking, but it can be done. Not quite that bad, but there are lots and lots of impromptu talks for the count of people. So typical audiences are small because somebody else is talking, and you get a lot of fun feedback and a lot of discussions. And he has day trips all around Crete, which are fun to go do.
So Kirk Pepperdine will often joins this call. He's one of the organizers now there, so you can always ping him if you're interested in finding out more.
Yeah. Did you say it's in Crete, in Greece?
Crete, yes.
In Crete, where Heinz lives.
July.
Oh. Ooh, yeah,
the beaches are amazing and gorgeous, and the heat is hot.
Yeah.
Humidity is high, heat is high, air conditioning is questionable at best.
Yeah. The Minoan Palace is kind of cool too.
The Minoan Palace is very cool. You make it to Crete, you go visit the Minoan Palace. I have gone to it twice now.
Yeah.
So I went with my kids once to Crete, to JCrate. And then later on, when I got married to Lisa, she was like, I have to do these things because you did them with your kids. It's okay.
It's worth it. That's great.
We were dating and talking when I went to Crete with my kids. So she got to hear all about it. And, we were on the late night Discord channel a bunch. Fine.
So in a tangential stretch to the not having reliable power question, do you think there's stuff we should do in our compilers to give programmers a better sense of what is power expensive? I feel like for years and years and years, the question was always, how much performance can I get per time? How much memory am I using?
Yeah.
And suddenly it feels like both in the data center and in the cell phone, the name of the game is how much compute can I get done before the battery is dead?
That's interesting. Yeah, cell phone's been that way a while. I don't think data centers, but sure.
I mean, a lot of it overlaps with just sort of general performance of if I'm not torturing the memory channels, I'm probably not torturing my power. But
yeah, it's memory.
Is there stuff we should be thinking about of like...
It's memory.
Well, this is the group that understands why I have automatic memory management.
Yeah. But if you're going to go there, I'm going to call you out and say, okay, you have to explain your shit. Because we all want it. We all know it's hard.
I don't know why it's so intuitive to me, but everyone else is like, but why does that work? I'm like, it's like I have to explain every single step, and I don't know what step confuses people.
So let me tell you my piece of the story. So I'm a young guy. I'm just in grad school. I have this cool technology for thinking about compilation. It's way the hell wider and faster than everything that's come before. I cannot explain it to my advisor, to anyone else around me. I eventually get 1 or 2 grad students to figure out what the hell I'm doing and why it's cool. But my advisor will not sign for it on my PhD thesis. So the appendix of my thesis is the sea of nodes that turns into the Java JIT eventually, right? But the main thesis is a piece of math that he was totally willing to sign for, but not how to make a compiler 100 times faster than what they had back in the in the 80s.
I'm kind of curious. How fast is the debug build in AA or any of the compilers you've done like today? Like how fast is the debug build?
Yeah, right.
Like with the bug information.
So I have to C2, which is the compiler in the Java JIT. C2 will produce machine code at 100,000 bytecodes a second into -0 level code quality that will also let you do, like I said, debugging and GCing, and there's a bunch of shit you can do there. Also, it's all profile directed optimizations, and there's a lot of stuff. That's a whole conversation everyone on this channel has heard me talk about a lot. Maybe you don't want to hear again.
That is a lot, but do you know what the source line count is?
No, because it comes from Java bytecodes. So this is a JVM compiler. It's not a Java compiler.
Yeah, but you can calculate it just by doing statistics on a big library in Java. You could compare the number of lines that it took.
But when you go from Java, you have the Java C time, which I am not part of. So Java C is not a terribly fast compiler. It's reasonable for its era and design. But
it's
not
ahead of time.
Fast.
Ahead of time compile.
Yeah, and it's ahead of time compiler. Whereas C2 is an on the fly, while you're waiting on your program to run compiler.
Mm-hmm. My understanding is you weren't planning a bytecode for AA. You were planning to have your AA runtime read code.
Yeah, I'm unlikely. I am likely to have an IR. I'm sorry, I have a .o format that would let you link against statically made binaries, the same as like a class file in that mindset, but in a .o mindset. That would have the full set of debug info and IR basically the typing's all incremental. So I could do full program typing in the linker if I wanted to.
See, I don't know how much TCC slows me down. It's probably very little. LLVM, absolutely. But using TCC, I'm getting 2.5 million lines per second. And everyone is like telling me that Go is fast. And Go is, I think it was like 120K per second.
Yeah.
And I'm doing 21 times.
To my language.
The difference here
I'm doing 21 times faster.
You've crossed the threshold where the time to get from high-level code to it can run now is already good enough. It's much better than
it's like an interpreted language. You just press it and it goes.
Okay, hang on. But what you then need to encourage people to use it is going to be some other aspect that can't be gotten some other way. So one other aspect is the output code is super fast because you're a supercomputer target, or your language supports something like automatic memory management, which is really cool, or you have a strongly typed system that can generate system level code quality or code for building an OS using strong typing or whatever. Something else needs to come along.
Or maybe it checks array bounds at compiles time. Wink, wink.
Java does that. And it checks array bounds mostly at compile time, but you can't check them all. So I get 100% coverage, but I have to do some runtime checks, right? And the trick is, how cheap can you make the runtime checks? That's another thing the Java JIT does. So
I kind of think I think for me, for my language, I think all I got to focus on now is getting examples working with with the standard library, and then actually being able to demo some of the things I already done.
Yeah,
I think just not being able to demo it is just hurting me right now.
Right.
Like that's
I'm not.
Yeah. Everyone keeps on asking me the same questions.
Right. I'm not shouting out what I've got with AA except to this very small group because I can't run anything. So there's no one to do anything with it.
Running is very overrated.
And even here, every week, I'm like, hey, Cliff, win REPL.
I could go turn the REPL on soon, but it will crash quickly because I have 100 failing test cases in front of me. So as soon as you hit one of those test cases, you'll just crash. So I could turn the REPL on. You could add 1 and 2, and you can do all those test cases I threw in the AA, the docs, the Google Docs. But you step outside some modest bounds, you'll hit an unimplemented or a syntax or crash or whatever. So actually, the REPL is not hard.
How do you deal with managing failing test cases? Because it's nice to have a fully passing repo of what you know works so that you can bisect and go back and whatnot. But it's also important to keep track of failing test cases and not forget about them. And I don't know.
So I broke my test cases out into sets of groups that tested various kinds of features. And I know that after the last major typing rewrite caused me to change some fundamental structures, I went back to test case 0 as I knew this. So I basically make a stack. I'm up to this point and my stack is working. And after that stack is a higgledy pile of non-working or non-tested tests. And then when I reach a point of stability of whatever, and I'm ready for the next thing, I turn on some new feature and I verify everything else is okay. And then I go look at my tests and lump them that are feature-wise toward that. And then I start working on those set of tests. But the rest, I'm at test parse 0, 1, and 2 run. Each of those internally has 50 tests. So I have 150 passing tests. I haven't looked at test parse 3, but I'll bet you it'll fail quick. And nor have I looked at 4, 5, 6, 7, 8, 9, and there's 500 more tests out there that I have not looked at. And these are all things that were working at one point, and I just had to back off when I changed some fundamental, type things.
I can tell you what I do, but I'm a compiler newbie compared to Cliff.
Fire away, guy.
Okay, so what I do is every run will run my test cases, and I have like maybe a dozen that I want to be ran like every time. Like they're very common, and they only take like a couple of milliseconds to complete. So it feels like not having it feels the same as having it. So that's just always enabled. The tests themselves aren't like functions. It's a file that it reads, and I have like maybe a dozen files with maybe another dozen functions inside of them. It's very simple. Then I have in my build script a complete set of tests to run. There are examples on my websites of all the examples I run on every execution, and then another folder that has more exhaustive and more specific tests. And I run those every time I do a commit. So yeah, it's just basically a commit and a dozen tests like being ran every single run.
So let me add you a question. For instance, suppose that we have a long involved discussion about how you're doing memory management, and we discover a hole in how you're doing it. But you think you can fix the hole, but you're gonna have to change something kind of fundamental in how you're tracking and thinking about memory, like your reference counting or whose job it is to free something has to be fiddled with. Promptly while you're doing this work, all your tests that allocate break. And as you get it homed in, more and more tests begin to work again. And what I heard out of Derek was, how do you handle the case where, as I'm working toward getting it all live, I go from having many failures to some more working to fewer failures, but for a long time, or long as weeks to months, I have tests that are just failing because I know they need a thing that I can't get around to because I'm fixing this other thing. But I know I can fix them, but I just can't do them both, so I got to do one first.
Well, in my situation, that would be just a complete disaster because everything would depend on those. But my string classes would definitely fail, but the the number class, the number file, maybe the classes, and a few other things will not.
Because there's fail fast, which we always think is good, right? But you actually have done something else, which is if you fail, it's so central to the concept that like it's not just fail fast, it's fail 100%, which is actually really good in a sense. It'll hurt, but it's actually a good design basis.
I mean, I had to go through that once because I had my first NanoPass version of the compiler, but it didn't have any optimization in it really. And I had end-to-end working, and I had lots of tests. And then I decided to first change the way I do my my namespace resolution, which broke nearly all of my early phase tests, and then they were broken, so all my late phase tests broke. So I was basically at 0 passing tests. And then I gradually got that stuff working, and then I decided to throw in the sea of nodes, and then that comprehensively broke all my late stage tests. And they stayed broken for a really long time, but now I'm finally getting to the point where they're going to start going green.
The one thing,
like I just have lots of test files that just fail, and I just know not to run them, but it's annoying. And every now and then I forget about some set of tests and I haven't run them for a long time. And then I have to go back and be like, oh, wait, do my lattice tests still pass?
Yeah.
And like, no, but sometimes they do. Or like sometimes I'm safe and sometimes, oh, that's where my problems are.
Have you considered tagging tests as like, this is a blocking test for a release, this is a blocking test for a whatever?
Yeah.
For me, I just fix everything.
I have a set of tests that my tests come in these layers, and I have to do one layer before I go to the next. And then the ones on the main AA parse language are at a higher layer, but they're now stacked where I have push pop stack. I'm going to do them in this order because they bring up new features in order. But I have a typing, the type lattice is correct, runs every time anything comes up. That's the same as Levo's. This is just run every time because it's too quick and it's too fundamental. And then I have this whole series of extra typing tests I asked for on demand. And when those pass, the type system is, the flow type system is stable. I don't have the equivalent for the Hindley-Milner type side, and I need to. I guess I do. I have the entirely unrelated implementation side, which has the algorithm tested super well, but is not in any way usable in any sort of mainstream way. That was the JavaScript and Java version. It's all things are strings. And now I'm back to, on the AA side, I did all the fundamental node crap. I did all the fundamental type things. I can now actually parse expressions, and those are a stack. So tagging via a stack. I don't know if that's a good plan or not.
Yeah. I sort of balance between not wanting to spend a lot of effort on maintaining and sort of meta managing my tests, and also having tests and knowing when things are broken.
Well, I have a test 99 because I didn't want to meta manage, and I grabbed some of the Hindley-Milner tests, which are very different from the flow tests, and threw them in, and we're mix and matching. And 99 was the short form for this isn't 0, 1, 2, 3, 4, and I don't want to order them right now. Hand in hand with that is I changed how the primitives worked because I did this overload thing, and I changed a couple other fundamental things. And the 0, 1 through 9 test sets are no longer stacked how I want to test them. So I need to meta manage. I need to go manage my tests, group up things that don't involve any primitives. That's pretty tough. Can't do an add because that was actually fairly complicated to do an add because that required you overload resolution of a lookup on an integer operator, right? It's like trigger all kinds of new shit. But I could now do Hindley-Milner map style type inferencing where you have a map over a collection and he would follow the function types through correctly. So I need to resort what do I think is fundamental and what is easy and what is hard. And so by the time I got to the end of 0 and 1, the test set for 2 went through in like 3 days. And I'm already staring hard at like 3 will go pretty quick because I had to do so much fundamental shit in 0 and 1, which didn't used to be the case. It used to be that those like just did add, subtract, and they tested other things, but add, subtract, all kinds.
So does that mean that you actually, you need to reorganize things so that the stuff that's in 0, 1 actually shows up in a later phase, and you have some simpler tests earlier on?
Yeah. Some of the things in 0 and 1 can stay there. Some of the things need to go later.
Yeah.
Overload resolution is complicated and requires Henry Milner working very well.
Yeah.
So I want to have that one, delayed, where I can.
It reminds me of the
functions.
abstract algebra textbooks, where you end up with all this crazy set theory at the beginning of the book, and then you get to page 205, and it's like, okay, so now we're going to talk about 1 + 1 = 2.
Yes, I have those books on that shelf behind me. They're brutal. Anderton's set theory book. It's like as thick as my thumb, and it's all easy, short words. And by page 3, your eyes are crossing and your head's exploding. It's amazing. It goes from, and this is a set, and we can add and remove, and we can say compare and less than and subset, and blah, blah, blah. And like I said, by page 3, your head's exploding. By page 4, you're at the axiom of choice. What's the damn Z guy's name that goes with the axiom of choice? Whatever. There's just like
Zelenko.
Say it again.
Zelenko.
Maybe. Yeah, maybe. I have to go pull it up and look. I don't know. It's axiom of choice still messes my head up.
Right. But I think that makes sense, because as you get fundamentally closer to understanding what you want out of your type system and inference and everything, the things that are going to end up fundamental are structs and types and function calls, and the things that end up not fundamental are add, which is just
my
all
weird
function.
Mill, which went through a twisty mirror maze where I kept flipping the plus and minus and the high and the low and the inverted and the not inverted to get it uniformly correct. But because as it, like a diamond, as it gets tighter and tighter and more perfect, one little flip, one little imperfection wrong here requires like the whole mirror change everywhere else to be done perfectly in the flip, except I don't know where the border is where I need to keep it, where the flip is. So the flippings of that is just really, really ugly. And I went through another one of those last week. And when that one settled out, suddenly I made a bunch of progress really fast. So never mind. My twisty maze of mirror passages all alike is what I was fighting for the past 3 months. Maybe I'm done with it.
Read some Borges and you can
Yeah.
He'll sympathize with you.
Well, what I want to sympathize with now is a hot shower.
But you
I can feel the heat. The house is caught up. I'm overdone now. I'm going to start killing things.
Did you just get power back there? Like
we checked into a hotel yesterday because power's out, so there's no pump, so there's no water, right? And no gas because that's what's running the power. So no gas means no heat. So we checked into a hotel. An hour later, the power was on. It was like 8.5 days with no power. Run that generator for 8.5 days. The day we ran out, an hour later, power's on. Fuck. But no gas still. So we stayed the night in a hotel. We came over to the house yesterday, and the gas people were like, we're going to be there today. We're going to be there today. Yesterday, right? And it was cold in the house, but it's a big house, and it's well insulated, so it's running downhill slowly, right? It doesn't just get freezing instantly. And they never
You don't have to watch out for your water pipes breaking or anything? It's not that cold.
No, we were watching that. It was very close. We were bouncing around the freezing line for a long time. Below freezing a few nights for a little while, but nothing bad. We were paying attention to that, yeah. And then the pump went out. And
that's when you write some bad code for your cell phone so that you can keep your hands warm.
Yeah, well, we can't even warm our batteries in our cell phones, though. So anyhow, power's on, and then, now we can at least get passive heating and heating from the electric heaters and whatever. So nothing was freezing, but the house was running around 50, 55. Tolerable, but not what you want.
Not super pleasant.
All yesterday, right? And then today, we're going to be there. We're like, yeah, you've been telling us that for a week. But they made it. They put in 430, 440 gallons on a 500-gallon tank. Apparently below, at this cold, at that low level of propane, it won't boil and you don't get gas pressure. So you can't actually do anything with it. He put propane in, heater kicked right in. It's been running steadily since whenever you saw me run and talk to them. The gas is here. It's Christmas. The gas is here.
Welcome back to modernity.
Yes. Yes. Fine. So I'll get a hot shower now and I'll have a hot lunch. Well, we had a hot lunch today too. Yeah, we had microwaves going. Once the power's back, the microwave's on. But no hot water. So that's better. All right. Anyone else with any final comments?
So ran into a nice little Python feature recently. So Aaron probably knows this one. Python. So when you're printing out like the value of a variable, you can put it in a template and just put an equals on the end of the expression, and it prints everything to the left of the equals. Then it adds an equal sign and then prints the value of whatever was to the left of the equals. So stealing that one.
Do you have an example of that?
Yeah, throw that in the doc. That sounded very good.
Aaron, you know what I'm talking about, right? You're a resident Python expert.
I think it's Python 3 only, but it's to solve the problem of people writing
I'll show you how
variable name equals brace, the variable name brace. Because often the thing that you want to print out is the name of the variable that you're printing out and the value, not just the value.
Oh, yes, of course.
So they are making it simpler to write, print out both the name of the variable and the value of the variable.
That's good.
Without having to type out the variable name twice. Because you're going to get super confused when you refactor and it changes the name of the variable name, but it doesn't change the name of the string before the variable name that was the variable name.
And this actually prints out the whole expression before the equal sign, and then what the result is.
Yeah. Oh, so you put an arbitrary expression to the left. You say dollar because of your format.
Well, this is, I don't know if this is Python, but this is Ecstasy. So I'm stealing the expression syntax, not the.
Okay.
So yeah,
this is close to Python, but not exact.
Okay.
This is something I always add when I'm, debugging in Clojure. I make myself a little macro that does exactly this. But
I did it in Java by loading on the fly the source code, parsing it, pulling out the variable name, and then showing it in the. So you could say like show X and it would say X equals 4.
I didn't do this with Java. Now I wish I had. I did this with C with macros, but not.
Yeah, that's easy. But you have to, in Java, you have to throw an exception, catch it, get the source code file name from that and the line number, and then go in, find the call to the show function.
So I was using, at H2, I was using Java Assist, which let me write Java code on the fly and then compile and run it, of course.
Yep.
And that one, we totally threw in debugging, extra Java code for debugging, which included what the hell is Java systems, which is typically serialization code for whatever is being passed around the cluster.
Yeah. I have another minor thing, which is something I just realized last night. I've sort of started being able to move on to other challenges and whatnot. And so, I have this whole like construct call site and then tear it down, and I can go back and forth between those representations. But I realized I've always known that when I tear down call sites for more complex function sets, that it'll sometimes be broken. So especially like, for instance, this example breaks. Let me just copy and paste. I'll just throw it in the document.
Code block for copy.
Yeah. Here. So this one is just this is from a test. So it's like basically calling functions where I'm calling the function to get the argument for the function. So it ends up with a very twisted path when you sort of put this all in the graph and it's all wired together. But this is not the simplest possible one. I've done some simplification, but this gives you the idea, especially that the definition of y, where x is called with calling x to get the result for each of the arguments. And so I realized that I just have to tear down the functions in order, because otherwise I don't know whether the building it works fine, but tearing it down, it doesn't know whether the arguments should be the inside or outside of the function call when it's saying where the, like it has an edge in the graph pointing from the function call to the argument nodes, because they float separately. And anyway, so I was very happy to, so it has to sort of follow that edge, find those things, and restructure the graph around the function call.
You remove some of the function call border when you wire the function call in.
Yeah, the function call it almost doesn't have a border.
Yep.
So it just has edges pointing to where the arguments should be. And then I pull it all back together, I create the border again, and I strip those, sort of cut all the edges.
Bijection.
Yeah. And so, but if I do it in order, then it has a defined way. I can do it either forwards or backwards. I just have to do it in one order. So, because everything I've been doing is like, by default, I do in random order, and I expect everything to be, So I was happy to realize where my problem was there.
I'm not currently, I don't know if I will ever, having two versions for calls, a sort of a dense one and an unpacked one. I'm only the unpacked one, which if I get far enough along, then unpacks completely and you've inlined basically.
Right, I was going to say it's like you'd run into that anytime you do inlining, especially with things that are recursive, which sounds like Derek, your example here is basically inlining or recursive in a sense.
Yeah,
because you have calls of x to x or whatever.
It ends up looking recursive in the graph, even though it's not technically recursive.
If you were to inline this one all the way, he'd bottom out. But if you had x call x recursively, you have to, you can't keep unpacking them. So roll forever.
Just need more memory.
So this is.
And that was always the Fibonacci question, is if I've got Fibonacci of 1,000 in my source code, it's entirely deterministic. You could just replace that with an int, but are you really going to go figure out Fibonacci of 1,000?
Well, there are people who have language features that said if you say constexpr, they'll run it at compile time. Of course, the Java JIT basically does that. The reason I threw fib in was exactly that issue. I have a fib of, I have a one-step inline rule. And so I'll do fib of like 2 or 3 perfectly. And then as soon as you say 4, I say, fib produces an int. And give it up.
Is that your widening
C++ ever settle their interactions between constexpr and file system operations?
I didn't know they hadn't. You would even do a constexpr on a file system?
So there was some issue of like, if you did certain things and you want to do constexpr, it's going to read the file on the machine that compiles the code rather than reading the file on the machine that runs the code.
Right, yeah, exactly.
Because that's what constexpr means.
Right.
But there was some issue with things that, I don't remember what it was. It was like a file handle got left open, or it pre-compiled something because it thought it was on the environment that was the compile time. And if you did certain things at compile time, it would make assumptions about the kind of machine you were. And then at runtime, when you were on a different CPU architecture, they were getting weird behavior.
Interesting.
Modes
are, but I don't remember the whole story.
That byte ordering would be a little bit confusing when you have a runtime environment that doesn't match a compile time and you have constexpr.
Well, just loading in the file system in constexpr seems fraught with like.
Right. So there's things where you want to make sure that you keep the constexpr version of it separated from the runtime version of it, so that when the compile ends, you can throw away all the stuff that was only necessary to do constexpr.
We have file and directory literals. We have file and directory literals. So, you say, like, let's say you're in a a file that's, test.x. If you say ./test.x, that is that file, right?
Why?
So
it's not the runtime version where I've moved the file system from your laptop to mine?
No. So for example, you could just say, ./test.x .contents, and you have the bytes of the file. So you've just read your source file.
Right, but in a constexpr kind of way. What I'm getting at is, in a ahead of time compiled system where they're doing a constexpr, the expectation is the binary will run somewhere else, and it will look at the file system at where it ran, not where it got compiled, where test.x is utterly unrelated.
Right. If you allow constexpr to operate on files, yeah, that's exactly what you'd want.
Yeah,
that's what I'm shocked or amazed, or who would have thought it would have been a good idea to allow constexpr to work on files.
Right. You read the entire file into a byte array.
Right. It's a really
using
good
constexpr, you should just have the byte array, and you don't have a problem with what do I do with this file.
Think about how hard.
The problem is if I try to read it into a file handle and then access the file handle at runtime that was created.
No, Aaron, that's still wrong. I got a file, a test.x, that has one letter, the letter 1, and I declare constexpr. I go compile the code. He wants to load up the 1 and constant fold it and carry on. I immediately take my binary, run it on Cameron's machine where his test.x has an entire ecstasy program in it. It's not got the letter 1 or the number 1. It has something else.
Right.
It should not.
It's quite useful though for things like web templates. Right.
I believe it's useful, but I need to be able to declare this is a constexpr file expression being run on the compiling machine, not on the.
Well, we don't have constexpr. We just have file literals. So it's a file literal. Therefore, at compile time, it's
when you say a file literal, you mean the compiler is allowed to look at the contents of the file and declare.
It has no choice. It's like 42. Like if you put 42 in your code, you have the value 42 there. If you put
if I put test.x as a file literal in my code and I don't have a test.x anywhere in sight, but I will run it. I don't right now.
No, it's a compiler. It has to be there at compile time because it's a literal.
Fine. Then you've declared it as it's just another piece of source code.
Right. Basically.
Yeah. I'm okay with that.
It's also handy because otherwise you have to have like 17 different ways of doing encoding of escapes and backslashes and stars.
Yes.
It's like, okay, if you want to put a bunch of funky characters in, just stick it in a file and
what I'm saying is the user declares a file literal.
Yeah.
Makes the choice. It's a constant at compile time as opposed to it's at runtime.
Yeah. I agree with that. Yeah.
Okay. The default behavior of constexprs should retain the C's default semantics, which is it's at runtime. And you can't do this at compile time unless I put something in the code that says, and actually it's a file literal. A file literal is a great name for that. It's fine.
I might tackle difficult things, but I'm not tackling constant expressions.
I could imagine a bunch of security problems over from an open source project with constexprs. It's like, okay, I'm going to take all your Bitcoin if you compile this.
On the one hand, yes. On the other hand, that's not worse than calling make.
That is calling make.
It is calling make.
So what do you guys use for
Bitcoin
builds?
is not worse than calling make? Okay.
I mean, I have downloaded things from GitHub and then typed make and let it do whatever bash can do.
You hope you have security on your system around your bash, yeah.
Yeah, there's a huge amount of trust when you download anything.
I mean, I think Rust has build.rs, which is a Rust program that it builds build.rs and then runs build.rs before it does the rest of your build so that it can go do things like turn your protobufs into code.
I had a, Java make that first step was to compile Java make and then relaunch the new binary on the new version of Java make. And then he went and did make like things.
What do you guys use for your home projects as a build system?
You don't want to hear my answer.
It's probably similar to my answer.
Well, my current answer is I use make.
Yeah, unfortunately,
inside an Emacs window. Emacs is my windowing OS.
I upgraded Gradle this morning, which of course broke my build because they renamed some of their methods just for the fun of it.
I used Gradle one time on a big project, and it failed reliably in ugly ways repeatedly.
Well,
and it was a giant, and everyone around me was swearing, no, it's the best thing since sliced bread. It was fucking slow and just wrong most of the time. And the Gradle make system was like, it encouraged you to get weirdly bizarre shit that you had to have a full-time senior engineer to keep the Gradle build going.
First of all, Gradle's not that slow on an M2 Max with 64 gig of memory and 78 cores. It's pretty okay.
You go scale.
Exactly.
But when they change the names of methods that you rely on in a literally 6-year-old build script, like frick, I barely know Gradle. It's not my life. It's it's kind of like
so why are you using Gradle?
Masochism.
Well, quit it.
I mean, what are the choices? It's like Maven or Gradle, and either way, you're screwed.
No. Make, stupidly, is actually still a good, fast, reliable, solid choice. You're like, no, it has all these horrible things. The syntax sucks.
It's a form of torture, but I'm sure Matt will now fill us in on what the best thing to use is besides make.
Does make do web developers even use make to build their JavaScript bundles?
No, of course not. Have I done make when
JavaScript? It sounds like make
yes.
doesn't do what it's supposed to be doing.
No, make
there are no good. Matt says there are no good build systems. Matt, by the way, Matt's mic is always bad, so he usually types things. So the chat's got a lot of stuff from Matt in it. But there are no good build systems is a good answer. I have tried many and have settled in on back to the old make. There's a discipline issue for all of them. And if you get out of control in the discipline for all of them, life sucks no matter what you do. And I found that I could do the discipline on make fairly easily. And the fact that the syntax sucks is sort of meaningless because the discipline just says I'm boilerplating shit in and I don't need the syntax means nothing. And the things that make gets right is it tracks the file system dependencies, which is the only unit of atomic state you get in a typical build setup. So if you're tracking other things than atomic file system updates, you're tracking the wrong things, which is one of the issues I had with Gradle. So I get my atomic updates, my stable, parallel, race-safe updates from make. And I can do parallel make, and I can do parallel make with other people in the same file system.
I think Gradle is perfectly fine if all you're doing is calling Java C once to build something. If you're just building one jar, Gradle's okay.
No, we're using make to fucking H2O. We used make to build 1,000 unrelated things.
Yeah, but you have more than one jar. I mean, how many companies have more than one jar, Cliff? Seriously.
Geez.
What about a Google
I use the
Bazel build system to build to?
Name's Google, you probably care.
I use the built-in thing that the Clojure guys did, so it's just CLJ. It works very nicely. I never have any problems with it. It's very minimalist.
Because you're building only Clojure.
Yeah, and Java. Like you can also build throw Java projects.
You're doing an R documentation and an R code with R test cases that are interlinking, and also you're doing Python, and also you're doing Python docs. And also we're doing Oxygen and Doxygen and 15 other things. And also we have other connectors. As soon as you get outside the domain of Go and Go format and Go whatever, or CLJ or this simple build system for Scala, right?
Yeah, and I'm sorry.
That's why I end up back at the build RS for Rust, which is there probably is a main language for whatever your project is. It feels weird to me that we're doing all this complicated build stuff in the make language rather than doing our build stuff in whatever language our thing is in.
Yeah, Scala tried that. It didn't.
When I used to do Ruby a lot, I used to use they had Rake, which is Ruby make. It was actually good. It was in Ruby. If you're doing Ruby, that's really nice. And it was just a dependency ordered thing, just like make, but written in Ruby. And so that was very nice. I like that a lot.
I mean, I did a Java version for the same reason.
So what was the Scala one?
Yeah.
SBT. Yeah. The simple build tool, but it was renamed quite a few years ago. The Scala.
It hasn't been simple for a long time.
When
I still want my shower and my lunch, and we're 2 hours in.
Yeah.
So I'm gonna moderate this one to death, and we'll have another one next week.
So we've all learned you can DOS Cliff's brain by saying build tools.
Obviously, a build tool is far more complicated than building hotspot because Cliff has never built a working build tool. So
I built quite a few. Thank you very much.
We'll start with build tools next time. We will revisit.
Start with build tools.
Oh no.
Oh yeah.
I want to hear someone's opinion on Anaconda. Anyway.
That doesn't sound helpful.
Next time, folks. Next time.
I'll have to visit my design for my build system. I have.
Bye. Alan, you're trying to troll again. Bye.
Next weekend.
Y'all.
Okay, bye.
Anaconda.